Welcome to the performance tuning webinar. Please let me introduce myself. My name is Pavel Miller and I am a ServiceNow architect focusing on integrations, and I'm also a SnowMirror product manager here at the Guide Vision. If you have any questions even after the webinar, please do not hesitate to send me an email. Just briefly, Guide Vision is one of the biggest ServiceNow partners in Europe. Our main expertise is ServiceNow implementations, and SnowMirror is actually coming out of our implementation projects. Some of you, because you are our customer, you might know we've been developing this tool for about 6 years. We've got more than 120 customers globally. I think there is plenty of expertise in the Guide Vision and SnowMirror area. So let's look at today's agenda. We'll be focusing on tuning the SnowMirror performance and also tuning the performance of the whole replication process. At the beginning, I will try to explain the background, especially regarding the SnowMirror architecture and how SnowMirror works with ServiceNow, because this has a tremendous impact on the whole performance tuning or the whole data throughput, to understand some of the basics. And then we will move to analyzing the bottlenecks in replication. So we will go through tools that SnowMirror offers, how to analyze some performance impacts, or how to see the current status of the tool. And then I've got several tips and tricks what I see within our user group that they are facing some issues, and also some of the more advanced stuff. So let's move to the first topic, the replication picture. The common mistake that we are typically getting, especially with the new users, is SnowMirror is, say, the performance bottleneck. Basically, the agent is the bottleneck of the data throughput. If you look at the architecture here, SnowMirror, as you might know, it's a Java agent running on one of your machines, and it connects via SOAP or REST API to ServiceNow, and it stores the data into a mirror database. And actually, the biggest bottleneck in the whole replication architecture is this part, the API calls to ServiceNow. It's from the network perspective, there is a big distance between SnowMirror and the ServiceNow infrastructure, and also API itself that ServiceNow provides is not really designed for high data throughput or bulk data manipulation. This is basically a transactional SOAP or REST API, and that's the bottleneck. If ServiceNow is sending responses slowly, then the whole data throughput is very low. SnowMirror itself is not doing that much of a stuff. It actually reads the HTTP response from ServiceNow, and then it sends the data to a mirror database without any transformation. The application server is not having high CPU utilization typically, and the mirror database, again, if set up correctly, the response times of the databases are typically very fast, and the database is typically in infrastructure as SnowMirror, so there is no network latency. So if you want to focus on the biggest bottleneck, then ServiceNow response time is the key. It downloads the data in batches. Typically for the SOAP API, as you will see, it is 250 records in one HTTP request. If it is a REST API, then it is 1,000 records in one batch. So SnowMirror typically sends many requests to the ServiceNow servers, and the whole performance depends how fast the ServiceNow is able to provide these 250 records or 1000 records, depending on the API. Something that you should be focusing on, we should be focusing on together. So first of all, you can optimize SnowMirror, that what we will be doing here, because, for example, to lower the number of requests or unnecessary requests to ServiceNow. Also, what you can do is talk to your ServiceNow consultancy team or ServiceNow admin team to improve the performance of the ServiceNow instance itself or the tables themselves. But this is not in scope of this webinar. We will be more focusing on setting up SnowMirror replication agent. If some of your tables are slow, you can fine-tune indexes, you can fine-tune business rules or ACLs on the ServiceNow side. You can talk to your ServiceNow support to make the performance better. But as I said, this is out of scope here. We will be more focusing on setting up SnowMirror correctly to achieve better performance. The impact on the whole performance is having this simple image, and you should understand how the SnowMirror data download actually works. Now, cloud instance is composed out of so-called ServiceNow nodes. These are basically application servers in the ServiceNow infrastructure that are handling the HTTP requests, not only for integration such as SnowMirror, but even for the end users. By default, ServiceNow creates 2 nodes for every single production ServiceNow instance. It's typically sufficient for most of the mid-sized or even slightly bigger customers. But as you are getting bigger with your ServiceNow usage and number of users, the ServiceNow infrastructure team keeps adding those nodes into their environment. So the whole cloud instance is performing better. And what SnowMirror does, and what is the biggest trick on our side, is that SnowMirror is able to identify individual nodes, now infrastructure, maintains by default, as you will see in the settings, it maintains 2 sessions with each and every node. So in this case, in this particular example, SnowMirror will be downloading the data in 6 parallel threads concurrently. Even if it is just one table, the requests will be sent in 6 separate threads to 3 ServiceNow nodes. As you will see, the key performance settings, if you are a bigger ServiceNow instance, is to set up the number of nodes correctly. Achieve your data through. By default, each ServiceNow node has so-called integration semaphores. This is basically a limit on the ServiceNow side, how many concurrent integration requests it can handle. By default, it has 4 integration semaphores. SnowMirror, again by default, is able to utilize basically half of the integration capacity of a ServiceNow cloud instance. Number of 2 is configurable. I will show you. You can set up not just 2, you can even configure, let's say, 4 concurrent sessions with each and ServiceNow node. But in this case, you would be utilizing much more and potentially affecting other integration. So there is a performance settings page in SnowMirror, and I will show it live. where you can set up the number of nodes to utilize and some advanced settings if you are not fine with the default setting. So this is one of the key pages to configure performance. Also, we will be using that. There is another menu in the settings which is called stats, and you've got so much important information. For example, how the sessions are being utilized, how the threads are being utilized. SnowMirror is measuring the response time here, which is the important. So this is a key page for you to analyze your performance of your SnowMirror. So let's look at live to my SnowMirror. This is a SnowMirror running on my laptop. I will be showing a couple of examples here. I am connecting to one of our vendor instances, which has unfortunately just 2 nodes. But if you go here into settings and performance, this is the key page. As you can see, you should, first step when installing your production environment, you should set up correct node count, which corresponds to your ServiceNow instance. We've got a very simple tool here, guys, your ServiceNow instance, to actually check for the nodes that are actually responding. So as you can see, I've got 2 nodes here. Fine for most of the users, but there are users having much. Now here in the advanced settings, these are the important numbers. This is the number of sessions per node. So in this case, the default is to use just 2 sessions with every node, and the number of threads that are handling or sending the request to ServiceNow. Default and the recommended value is that if you have 2 nodes times per node, then you've got 2 times 2 is 4. It applies to number of available HTTP connections that are available for the whole SnowMirror agent. Have a look. If I reschedule or reconfigure it to, let's say, 4 nodes, if I had a bigger instance, 4 nodes, then again I've got 4 nodes. I keep the default is to keep per node, but in this case you've got 8 threads for downloading the data. So let's keep it to default now, and we are fine with that. Let's run some of the synchronizations here. Have some traffic. I've got these big tables. Do clean and synchronize to have some traffic. Start the download. Here is the stats page, which is the first point where you should go when analyzing SnowMirror performance. There are several sections here, basically corresponding to the settings on the performance page. HTTP connection pool. From time to time, I will refresh the page. I'm pressing F5. So as you can see that you've got maximum 4 HTTP connections, but you're utilizing just 1. This is fine. There is the worker thread pool. This is basically the activity. So we've got 4 threads for downloading the data. And you can see all of these threads that are named W1 to W4. All of them are working right now. You can see each table. These guys are working. You can also see how long the request currently takes, this duration. If this gets very big number, then it means that the request is getting stuck somehow. And also you can see that the task to download this particular batch was queued for 15 seconds. By analyzing the data here, actually see what is happening inside SnowMirror, which table is currently getting the attention, and how long the tasks were queued, and how long it takes to download. And the next one is displaying the sessions that were established individual ServiceNow nodes. You can see here we've got two groups, node number 1 and also node number 2. The correct setup here is that the session slots, as I call it, the session slots should not be empty, and typically the session was created some time ago. So for example, I've got like sessions that are 2 hours old here in Europe. Next session is about your database. You can see if your database is performing correctly. We've got like 6 connections to a mirror database. Basically, just one is busy again, so nothing really on the database side. Then basically the most important section here is the ServiceNow response time. As I was explaining, the bottleneck of the whole replication picture, and you can see what was the response time in last minute or 5 minutes or an hour or in the last day. Number of transactions and how many records and so on. Basically, the most important value is ServiceNow response time. If you have a response time, I would say up to 2 seconds, you are fine. If you have a response time lower than 1 second, then you are very fast. But if the response time is getting like over 5 seconds, then of course the whole data throughput is much lower. So this is a key value, and basically a very simple math applies. If you have a response time of 1 second, and then if you have a response time of 2 seconds, then it's basically slower. Your goal is to have as healthy ServiceNow instance as possible. You get the lowest response time. If you have a higher response times, you can several types, or you can check the response times on individual nodes. Typically, this section is enough for analyzing you are getting enough response time from ServiceNow or not. And then there is information about some clustering, but this is not important for ServiceNow. What for data throughput? You can also check status. Some of the bigger users might be having issues with the memory allocation, the place where you can check current Java heap size. So this is an extremely important page to analyze the overall performance. If you want to analyze, let's say, individual performance of individual tables, so imagine you've got an issue, a single synchronization, there is a hidden gem or secret in the logs. So for example, having 8 minutes for this system dictionary, let's analyze what is happening here. What you want to do is to go to the log and see the data. If you go to the very end of the log, there is here at the very end this section times these 3 lines. And these 3 lines are telling you how long individual sections took. So for example, acquiring metadata for this table took 3.5 seconds. And no auto schema update was happening. This was good. then counting the records to download, seconds, then downloading the data, 7 minutes and 54 seconds. Delete strategy, 0, and then the last consistency check. Typically, what you can see here is, especially when configuring synchronizations incorrectly, you can see that, for example, the data download 1 minute, but then it took 5 hours to perform the delete strategy. Right? So this is a best start for analyzing, the biggest impact. If you have like big issues and the delete strategy might be taking too long for you, you want to reconfigure a synchronization, right? So this is a good start. Now let's move on analyzing typical issues with SnowMirror we see with our users. So right now you can see that 3 synchronizations are running. Let me start a 4th one. So now 4 of these synchronizations are running. And imagine that these synchronizations are for very big tables like syslog or sysaudit or some big, really big table. And it might happen that these synchronizations are set up incorrectly. Those guys are basically occupying the threads. And then an hourly update for an incident table comes. Press this synchronize button. A schedule might come. As you can see, it is not starting, it's just queued. The same applies if I start another table. So this is basically the biggest issue of our users, because like the scheduler threads are being occupied by some incorrectly configured synchronizations. The rest of the synchronizations are simply queued because there is not enough in the thread pool. One of those big guys finishes, those guys are queued. So you have to, let's imagine that I will stop one of these until one of these finishes are queued, then they are able to start. Them. See, by default, this is like a default configuration. By default, you've got 4 threads that are handling the synchronizations, but also 4 threads that are downloading the data. You can see only 4 of the synchronizations can run in parallel. Now, for bigger ServiceNow instances, you want to change this setup, and this is being done here, performance settings. Let me recap. We've got 4 threads downloading the data. These are completely different threads for number of synchronizations that can run in parallel. There are 2 completely different thread pools. One of them is limiting the number of tables that are running in parallel. Others are basically sessions to ServiceNow. So 2 different settings affecting completely different areas for the agent. Here, if you want to, let's say, extend the number of tables that can run in parallel, modify this number, synchronizations count 10, and save it. This is typically the number 1 option or settings you want to do. Unfortunately, if you change this, then you have to restart SnowMirror. So let me restart that for the tool to come up. And let me show you once again. Well, everything you change on the performance page, after you save it, you have to restart SnowMirror for the changes to take effect. Because if you change anything with the threads are being created only during the startup. If it has helped, like clean and synchronize for all of them. As you can see, now 10 of the tables can run in parallel and just 2 of them are queued. The default settings for SnowMirror is being a bit realistic because, of course, if you increase the number of threads, then the memory consumption is higher. You might want to extend the heap size for the tool. This is something that you should check, and you can see the running. You go to dashboard here. You can always see here with the link show queue running synchronizations and also the tables that are basically being queued. And if some of the tables are hanging there for a long time, you want to reschedule or reconfigure the number of tables that can run in parallel. So now let's move to the topic. I would say that like number 2 performance that we see is not understanding correctly the load types. We've got the initial load, or what we call clean load, via clean and synchronize. This is when you truncate the table and load all the data from scratch. This is expensive. SnowMirror is designed as an incremental tool. It downloads only the deltas, just the new records. It downloads the updates as well, and then it has a delete strategy for removing the deletes. This is the type you want to run basically every time, unless there is an exception. Right? So if you want to schedule your tables, your synchronizations, prefer from the performance point of view, please always prefer the incremental load. The differential load is basically a load to fix data inconsistencies. It downloads all the sysids, it compares all the sysids with the database, then it downloads the missing records. Because we are downloading like hundreds of thousands of sysids or even millions of sysids, this is again very expensive. So you have to think, want to run this differential load or even schedule a differential load for tables, let's say bigger than 500,000 records. So let me show you an example. We've got a task here which might seem to have an issue. So if I go to a log or if I check the scheduler, this is one of the, let's say, misconfigurations, because the task table is typically very, very big. Most of these ServiceNow instances containing hundreds of thousands or millions of records. You can see that basically the incremental is disabled. Every hour there is a differential synchronization. So if this table had 1 million records, this will be downloading millions sysids every single hour, and then realizing that there is like a few tenths of new tasks, and downloading a few tens of records. Definitely a misconfiguration, and you have to be very careful with this type of configuration if a table is bigger. You basically want to disable this guy like that, and you incremental every hour, and only if there is a mistake or if there is data consistency, you can run it manually. Also, there's this priority thing. Again, for performance, it might be important because the higher the performance, the faster it gets to the queue. It goes faster to the threads, and it is allowed to consume like bigger portion of downloading threads. If you have a very important, let's say, critical reporting synchronization, you want to give higher priority here to avoid the collisions with the slower big tables like sysaudit or something. This is an important setting. You know, it might sound as a basic, but we see many mistakes with configurations in installation. Number three, third biggest mistake, and what typically makes SnowMirror much slower is a delete strategy. So there are several options how to set up a delete strategy, and by default there is an audit delete strategy which checks the system journal, sys delete, and this is just a simple query, really getting 0 or just a few records that were deleted. This is typically cheaper or cheap strategy if the sysaudit delete table is fast enough. That's the topic for your ServiceNow guys. If they are having the table, you know, performing well. On the other hand, strategy is basically very expensive because again, it's very similar to the differential log. It downloads all the sysids, compares all the sysids with the database sysids, then it removes deletes. So this is very expensive, and we typically do not recommend using this strategy for tables that are bigger than just several hundreds of thousand records. So this is not the strategy. Tables bigger than 1 million records, because it will take several tens of minutes or even hours brute force comparison. Next, we've got this fast difference strategy, but again, you have to understand how this works. We realize that there are many tables that are not experiencing any deletes. So this different strategy was just, you know, too much because it was downloading all the data and then realizing that there was no delete. The fast difference strategy is kind of optimistic. Just compares the number of records on both sides. If the numbers match, and basically nothing. It skips the whole brute force comparison. But if there are some differences, so there might be some deletes, updates, then it splits people into several sectors, and again it compares the numbers. So if there is like high traffic, if it experiences a lot of updates or deletes, then this strategy might be even slower than the different strategy. So this is a strategy for tables that are not being changed that often, that are very big, that are not experiencing that many deletes. Then the fast difference is a good one. And then perhaps from the performance perspective, the most important one is the non-strategy table that is just a write-only table, such as sysaudit, metric instance, or sysemail, and I don't know, sysjournal field, and so many others. Then you want to set up the delete strategy to none, because there's no delete happening, so it's less for checking deletes, basically. Let me show you a sys audit right here. I go to settings. This audit itself is set up to an audit strategy. So this is a misconfiguration. It doesn't make sense to check for deletes in the sys audit table. You want to set up a none strategy. Even for tables that are where the deletes are, let's say, rare, again, from, let's say, performance perspective, if you want to improve performance, disable the delete strategy so it gets much faster. Delete strategy, a very, very important one. Let's check the task table. A different strategy for the task table. This doesn't make sense. Task table has typically more than 1 million records. We want to have an audit strategy. Of course, the table has to be audited. If a table such as incident or CMDB is not being audited, please discuss this topic with your ServiceNow consultants, because then you are facing a bit. CMDB might be a tough discussion, because some of the customers or some of the ServiceNow customers are disabling auditing for CMDBs because of discovery and many automated stuff. But from the SnowMirror perspective, it's much better to have an audit table than a brute force comparison. I would prefer an audit here for the task table. Another topic, and this is, let's say, a bit more advanced, is filtering the data. The thing is that if you filter the data, the good news is that you are downloading a smaller data set. On the other hand, for an incremental load, this means that the algorithm is getting more complicated. And that's what I'm trying to express here on the slide. The algorithm has to check for records that no longer match the condition. If you have a condition for incident priority 1, you want to remove all of the incidents from the database that the priority from 1 to, let's say, 2 or priority. And the only way how to do it is to download basically all the updated incidents, and then without actually applying the filter, and then check for those deletes. So this is an expensive operation. If you have a write-only table and you want to disable this advanced setting, which we call download all updated, basically stop checking for those kind of deletes. Where we see this mistake typically, it is or a misconfiguration, again, with a sys audit table or metric instance and many others. Check my mirror here. Check sys audit. As you can see, I have a filter. This is not like a real world filter. The filter would be typically table name equals incident or something like that. You want to download just a subset of a sys audit table. But then, because this is a write-only table, you don't want to be checking all the data. And it's here in advanced settings called download all updated. If you disable property, then you can typically, cut the whole replication time to half or even less, because it depends on the filter, because you would be downloading much less data in this case. It's like a very, I would say, hidden setting, but very important, especially for the big tables. Save it, and now the sys audit configured correctly. We built the delete strategy. We disabled checking for updates that could cause removes. Scheduler is incremental. This is a correct setup. In this case, you would also want to check the sorry guys, we've got some background noise. I will try to mute all of you. Sorry. I just wanted to say, if you focus on the sys audit table itself, to talk to your ServiceNow consultants and introduce some of the indexes. This is typically a super huge table, and you need some ServiceNow side indexes as well. But this is really a special case, and you have to tune it on the ServiceNow side. Basically, the last topic I've got here, table rotation and extension. As you might know, there are some tables that are split to so-called shards. Those are the tables with the numbers. For example, syslog transaction or sys email, or some of the users or some of the customers have extended sys audit table. For example, they've got a new shard, a new table for every single month. Extension rotation is that you've got, let's say, 10 tables, and you rotate the tables, for example, every week. This is a ServiceNow feature, and the thing is that ServiceNow creates, let's say, a virtual table on top of these charts, and it performs a union on top of these charts. And this is an expensive operation on the ServiceNow side. See the quote here from the ServiceNow documentation, that if you run a query where a sys created on or this timestamp is not being used, that it forces an inefficient union query. SnowMirror has a new feature. We've been having this for about a year or 9 months or something like that. There is a table rotation and extension support, and you typically want to enable this for performance reasons. If you do not enable that, then I would strongly recommend you to disable a consistency check, because you want to avoid this kind of union. And the union is typically caused by the consistency check, because the count query, like the select count star from sys audit, this causes the big union. The incremental load is not actually causing performance issue. Now, let me show you in SnowMirror. If I am creating a new synchronization for this kind of rotated or extended table, let's say it's gonna be sys email. No, it's not rotated here. Syslog transaction. You can see that these are the shards, numbered tables. I think I've got it already. Anyway, the option that helps you with the performance. By default, it would be like downloading the data from the virtual table, like ignoring the shards completely. If you enable this replicate and merge shards, SnowMirror will download the data from individual shards, the physical tables, and it will like compile the data into a single target table. You can even have like the numbered tables as a destination database. Please go through your tables or through your synchronizations and consider switching to this new option, replicate and merge shards, because the result will be the same, but performance better. Perhaps the last here, sometimes we are getting questions regarding configuring some custom settings. As I said, you can manually increase the performance by increasing the number of sessions. For example, if I want to double the performance, like say I will utilize all of the semaphores, then I've got 2 times 4, I need 8 worker threads to utilize all of the sessions. Also need 8 HTTP connections. Right now, I have just doubled the performance, but of course, this is a kind of dangerous setting, because you could be affecting other integrations because you are utilizing ServiceNow much more. It could be an option for, let's say, some initial loads or some testing. This is a nice trick how to make your SnowMirror much faster, and then you can lower the setting, for example, for the normal operation. We were talking about number of parallel tables. I would typically recommend you to consider increasing the number, because the default is, let's say, very pessimistic. And there is like the settings for the batch size, for example, how many records to download a single batch, how many records to insert to a database. My experience, this is not having a significant impact on performance. There are some users modifying these numbers. It can bring 2% increase. It depends on your ServiceNow instance. And also, please be aware that different tables are having different characteristics. For example, if you increase this batch to 1,000 records, it could be faster for, let's say, a sys audit table, but it could be slower for a task table. Typically, the task and incident tables, these are the troublemakers. In my opinion, you don't have to modify this option. By the way, what is coming in SnowMirror 4.5? There will also be a thread pool for inserting the data into a database, because we are working on a Snowflake data warehouse support, which is a cloud solution, and SnowMirror now requires a separate thread pool for also inserting the data to the cloud to fully utilize the source ServiceNow. So there will be another thread pool, another to optimize the data throughput, but for, let's say, typical users having local on-premise databases, will be a big difference. So let's look at the questions. So please type your questions into the chat window. I will try to answer them. There is a question from Ruchi or Ruki. Please tell me how frequent can we schedule the updates in SnowMirror from now? Yes, this is a good question. SnowMirror allows you to do updates, let's say, every minute. Switch to periodically, you can download the data every minute. If you try to save it, there is a warning saying, do not recommend a schedule like lower than 10 minutes, because again, you can put significant load on your ServiceNow. So the best practice here is to have a smaller set of tables, replicating more often, let's say every hour or every 15 minutes, and the rest of the tables just download once a day. question again, if you can create custom fields within SnowMirror tables. No, this feature is not supported. I would recommend you to use database tools, copy the data into your destination. Another question from Ambadas: how does SnowMirror understand the ServiceNow node to connect? Is this something that has been agreed with ServiceNow, as they don't recommend directly connecting to nodes? Yes, and they keep resizing the production. So yes, this was agreed with, we are a ServiceNow technology partner. This was agreed with the ServiceNow architects. Of course, this is some kind of a hack, or let's say this is an undocumented feature. ServiceNow officially recommend that because we are avoiding their load balancer. But this is the only way how to get to higher data throughput, because otherwise the ServiceNow load balancer would be directing the traffic just to node, which would have performance because there is this limit of 4 semaphores, and you also want to balance the load across the whole instance. So I think they are pretty fine with that. The question from Dan: do you set all nodes in the node count? Will this impact performance of the node? Typically recommend using all of the nodes that are available, because exactly you want to balance the load across all the nodes. You don't want to like overheat only some of the nodes. There is a feature on our roadmap. We want to allow our users to actually select the nodes they want to use. Right now, you've got just a number here, so you get a random node assigned, but there will be a feature in the future to select the nodes you really need. Chris, AZ, you've got 5.5 seconds response time, most likely. This is pretty high. So I would be talking to your ServiceNow guys if you can get lower somehow. Which one has better performance time, SOAP or REST? This is a question from Ambadas. Typically, the REST API is a bit. Unfortunately, we are having several users that are the REST API is slower. And the SOAP API is more stable. It does not tend to time out. So we typically recommend using SOAP, but the REST API is, I think, stable enough if you tune the timeouts. Let's say lower the failure rate or ratio. An interesting question from Kundan. For incremental load, sys updated on column is the only option to pull changes record. Can we set up custom column for incremental load? Yes, you can set up. You can set up a custom column. It is here in advanced settings. An incremental column is here. So if you have a custom column, you can do that. I don't think it will have a performance the strategy isn't deleting ServiceNow record. It's only deleting records in SnowMirror. This is an answer for Dan. Question from Jimbo. Would you recommend disabling the consistency check for the sys audit table, which has 100 millions of rows, and do a differential sync, say, on the weekend when activity is lower? I think I would disable the consistency check unless there is a big issue with that. So I would keep it as it is. and extended this audit table, then I would switch the configuration the way I was explaining. And what is the best practice? What the others do? I would run audit table overnight in some off-business hours. So I think running it over the weekend is like a too long period between the loads. I think once a day in during the night is the way to go. Miroslav, any news on Snowflake availability? Yes, we are working on it, and we are expecting the release October. If there is no big surprise in the Snowflake data type mapping, which we are working on right now, it will be available soon. Lusky, I have discovered 12 nodes. Should I change the node count to higher than 2? Yes, John. You have to switch to 12. This will make your application 6 times faster, right? Or basically 6 times faster, because ServiceNow is scalable quite well. I think they are very good at that. If you have 12 nodes, John, then this webinar definitely applies to you. You will have a lot of data. You have to be a bit more careful when configuring the whole tool. If you are not sure, please talk to us. I think we've got plenty of experience. This is all of the questions, guys. Thank you so much for joining today's call. I will share the recording with you as well, and it will be on our YouTube channel and on our website. Thank you so much, guys. And if you have additional questions, please drop me an email. Talk to you soon. Bye.